Let's take a moment and imagine creating this headset assembly, one component at a time. The components are a close fit with each other. The challenges quickly become apparent. After completing one component, how do you ensure that the complementing component matches up to it? The problem is further compounded when you need to make changes. How do you make sure that changes from one component propagate to the other complementing components in the assembly? This is where the master model or top-down design approach comes in. What exactly do we mean by a master model? Put it simply, the master model is a starting block of material that represents the overall shape of the assembly. This will serve as a template from which we will split into the various components. The first step is to decide what to include in the master model. We have the master model prepared here and the finished assembly at the side for comparison. We want to identify an overall shape that best defines the whole assembly, or at least most of the assembly. If you find that each component has a distinct shape that does not really complement the other components in the assembly, then perhaps the master model workflow might not be suitable. This headset assembly consists of 3 components that can move relative to each other. In their neutral positions, all 3 components share a common surface, which has a slight curvature. It is pretty clear in this case that these surfaces shaded in red can be carved out from a common block of material. However, the part of the headset that fits onto the ear looks out of place and disjointed from the rest of the assembly. So it will not make sense to include this in the master model. It would be better to add this in later as a detail. So in our master model, the part that attaches to the ear has not been included. Once you have decided on the overall shape of the master model, the next thing will be to look out for any details that straddle more than one component. On the sides, there is a common chamfer. There are also these aesthetic lines that cross more than one component. These features should also be included on the master model. I have taken the decision to not go through the making of the master model. It is quite involved and will take away from the main focus of this video. I will leave a link in the description for you to download the master model. In order to shorten the timeline, I have grouped all the features in creating the master model. Anytime that you wish to view these features, you can expand the group by clicking on the plus sign. If you are not keen on downloading the file, I would encourage you to simply sketch a rough shape to serve as the main body. Remember, the key here is to understand the workflow. Dimensions do not matter here. Do take note to extrude the body symmetrically about the top plane. This will make things a lot easier. Here are some key points to take note when it comes to creating the master model. Usually, at the beginning of every design, users are encouraged to start a new component. But in this case, it is more appropriate to create a master model at the top level. This will mean creating the sketches on the primary planes of the top level. The main body would also be extruded at this level. Once you finish creating the master model, the next step will be to split the body into the individual components. You will need to create sketches to define lines along which the body would split. Look out for the split line sketch in the Sketches folder. Go to Modify, Split Body. Select the main body to split. For Splitting tool, click on the Select box and select the 2 sketch lines. Let's uncheck the Extend Splitting Tool option, since I have already overextended the split lines. Let's rename the bodies as follows. Ctrl select all bodies. right-click, and create components from bodies. You can see that the bodies folder has disappeared from the top level. We now have 3 components. Together, these 3 components form an assembly. The top level icon has turned into an assembly icon. The previously split bodies now reside in the bodies folder of each component. Go to Inspect Component Color Cycling. This will give each component a unique color. You can change color by right-clicking and going to Cycle Component Color. These colors correspond to the colors in the browser. Now that we have the individual components, here is where we start to add details that are unique to each component. We need to add a clearance between the ear cup and the end frame. We can do this by offsetting faces either on the ear cup or the end frame. Let's do this on the ear cup. Whenever you need to edit a certain component, you should activate it by hovering over the specific component in the browser and clicking on this radio button. If you have active components visibility in your preferences toggled on, you should see the other components turning translucent. You can also see that the timeline becomes truncated, showing only features that are relevant to this component. In this case, only the component creation step that created the ear cup component is shown, hiding all other steps involved in the creation of the master model. Go to Modify, Offset Face. Let's hide the end frame so that it does not get in the way. Select these faces and adjust the offset. Put in fillets at the 2 bottom corners. And also the top face. Let's bring back the end frame to check on the clearance. If we activate the top level, this causes all components to return to full opacity. The timeline now shows all steps in the master model creation process and the previous steps that we added for the ear cup. You can differentiate the steps by matching the colors in the timeline to the colors in the browser. Now, we will create a portion that attaches to the ear. Since this is part of the ear cup, activate the ear cup again. The timeline is now back to showing steps that only pertain to the ear cup. Create an offset plane a certain distance away from the top plane. Sketch a slot on this plane. Turn on the origin within the ear cup and dimension with respect to this origin. Activate the Surface tab and extrude the surface using this sketch. We need to create a smooth transition between this chain of edges and the slot surface. Make sure that the Surface tab is still active. Select this face and press the Delete key. With this surface deleted, this body becomes a hollow surface body with a missing surface. Go to Create, Loft. Check on the Chain Selection option. Select this chain of edges as the first profile, and select this chain of edges as the second profile. Adjust this handle to try to get the transition as smooth as possible. Go to Create, Patch. Check on the Enable Chaining option. Select this chain of edges to patch up this hole in order to create a watertight surface body. Right now, this is still a hollow surface body. Go to Modify, Stitch. Box select all surface bodies and stitch them into a solid body. We are done with the detailing of the ear cup. Let's activate the top level and take a look. Next, we shall proceed to add details to the end frame. Let's activate the end frame. Activate the Solid tab. Go to Modify, Offset Face. Select this end face of the frame and adjust the distance. Repeat the Offset Face command on this face. Next, we need to create a protrusion on the end frame that allows the swivel to rotate with respect to the end frame. Begin a sketch on the top plane. Project this line. Start a vertical line from the midpoint of the projected line. And add another 2 lines to close off the profile. Change this line to a center line. Let's hide the swivel for the moment. Go to Create, Revolve. Because of the existence of the center line, the profile and the axis have been automatically chosen. We need to trim off this excess. Go to Modify, Split Body. Select the end frame as a body to split. For Splitting tool, click on the Select box and select these 2 faces. Let's extend the splitting tools. Expand the bodies folder under the end frame. Control select these 2 excess bodies. Right-click and remove. Let's bring back the swivel and activate the top level so that all components become opaque again. You can see that the protrusion from the end frame overlaps with the swivel. Instead of creating a sketch and making a revolve cut, we will use the end frame as a cutting tool to create the necessary recess. Since we are modifying the swivel in this case, we should activate the swivel. Go to Modify, Combine. Select the swivel body as a target body. For 2 bodies, click on the Select box and select the end frame. Set the operation to Cut. Keep in mind that we are using bodies from different components within the same feature. This highlights the flexibility of working within an assembly. We need to retain the end frame after the operation, so check on the Keep Tools option. With this workflow, when we make changes to the protrusion of the end frame, the recess on the swivel will also change parametrically. Let's create a clearance for the joint. Go to Modify, Offset Face. hide the end frame. Select this face and adjust the offset distance. Bring back the end frame. Activate the top level and create a cross section to take a look. Next, we will be creating cylinders on both sides of the ear cup to form a simple revolving joint with the end frame. Activate the ear cup and perform a sketch on the top plane. Draw a straight line. Dimension with respect to these corners. This forms the axis of rotation. Go to Create, Pipe. Select the sketch line as the path. Set the section shape to circular. Adjust the section size, which in this case will be the diameter of the cylinder. Set the operation to join. Similar to how we create the recess in the swivel, we will use a ear cup as a cutting tool to cut into the end frame. Since it is the end frame that we are modifying, activate the end frame. Go to Modify, Combine. Select the end frame body as a target body. For tool body, click on the Select box and select the ear cup. Set the operation to cut and check the Keep Tools option. Again, we need to create a clearance by using the Offset Face command. Select these two faces and adjust the offset. For the joints here, I have chosen to use very simple features to keep this exercise as simple as possible. In an actual headset, the mechanisms are probably more sophisticated than that. We have finished detailing the components. To be able to simulate motion between the components, we need to define joints. Since the components are already designed in place, in their neutral positions with respect to each other, we shall use as-built joints. At the moment, the components can be dragged out of position. You can return them to their original positions by going to Position and Revert. First, we need to define an anchor component. These components will be fixed in space, and all other components would move relative to it. I will designate the swivel as the anchor component. Go to Assemble, As-built joint. To anchor the swivel, we need to tie it to the origin of the top level. Click on the top level and click on the swivel. Select Rigid as joint type. This will fix it in place. If you drag it, it no longer moves. Repeat the as-built joint command. Select the swivel and the end frame. Set joint to revolute. We will be prompted to place a joint origin. Let's select the revolve face of the end frame protrusion. Once we confirm, we can try dragging the end frame to test this out. Repeat the as-built joint command. Select the end frame and the ear cup. Set joint type to revolute. Let's select this cylindrical face. If you try to drag on the ear cup, you can see that the whole assembly moves as a chain. My experience with joints is pretty limited. If there's anything that you think is wrong or can be improved upon, do feel free to leave a comment below. By itself, the components here are probably not manufacturable. You might need to further break each of these components down. For example, if this is to be injection molded, you might need to split the components further into halves in order for this to be assembled together with internal electrical components. To do that, we can go one step further and repeat the master model approach at the component level. Let's activate the swivel. Go to Modify, Split Body. For body to split, click on the swivel body. For splitting tool, select the top plane, which bisects the body. In this case, the swivel body is acting as the master model. Locate the swivel in the browser and expand the bodies folder. Rename the bodies. Ctrl-select the two bodies and convert them into components. Now you have a swivel subassembly. Take note also of the change in the icon. These two components have been further indented towards the right to show that there are child parts under the swivel subassembly. From here, you can activate each half and perform further detailing such as shelling and adding bosses for joining the two halves together. The power of the master model workflow is fully realized when it comes to making changes. Let's say that the assembly has been completed and we decided that we would like to change the way that components are split. We can go back into the split line sketch that was used to define the way the master model was split. And adjust the sketch. Once we confirm the sketch, the whole assembly should regenerate accordingly, from the way the components are split right down to the details. We do not need to worry about the mismatching of the components. We can even make changes to the overall shape of the master model. Do take note that in actual practice, the more drastic the changes, the more likely the errors will appear in the timeline, especially if the changes result in new faces or edges. You should still be able to go into each feature and address them accordingly. If you want to learn more about the master model workflow, here is another video that you can go through.